All right. Good day, everyone. I have a very simple question on chemical kinetics to quickly show you. I saw this question in some A-level examination, and I saw it in the International Union for Olympiad examination. That's one of the questions, one of the International Olympiad questions. Okay, and this question is very simple. It's on chemical kinetics. It says the half-life of a first order reaction, to be precise, reactions can be classified based on order in other chemical kinetics. We have first order, second order, and third order reactions. Okay, now this reaction is a first order reaction, as I said. Okay, so the half-life of a first order reaction, this is the reaction, is 60 minutes. So half-life is 60 minutes. So every reaction can have half-life. Time taken for the reaction to be completed by half, okay, to go or for half of the product to be formed. Okay, the half-life is 60 minutes. In what period of time? So what time will the concentration of this guy be 1.0 piece be, pardon me, what time will the concentration of SO2Cl2 be reduced 1% of the original? Okay, simple. Now, the question is trying to say, okay, let's say this guy was 100%, given that this guy will become half of its original value in 60 minutes. Okay, what time will it take for this guy to just be 1%, to just drop 1%? So that means what time will it take for it to be 99%? That's what the question is saying. So, initial time, if you're good at chemical kinetics, initial time should be 100%, and final time should be 99% because it's going to drop by 1%. That's what we're trying to solve here. Okay, initial time is 100%, final time is 99%. AO is original of the initial concentration of the reactant, 100%. So now quickly, the first thing you have to do in such a reaction, because now this is the integral rate law expression of a first order reaction. Yes, it's an exponential equation. The integral rate law expression of a first order reaction, just like radioactive decay. So this is for first order reaction. So this is it. So ln final over original equals to minus KT. That's how it is done. So K is decay. What's it called? K is rate constant. Rate constant. So how do you get rate constant? You can get rate constant from half-life, and it says half-life is 0.693 over K. 0.693 over K. That is half-life. Okay. So now I'll quickly impute that to try and get K. So there's a little error here. So if I impute that to try and get K, I'll try and make K subject of the formula. So I already have half-life to be 60 minutes. Okay. So I'll try and make K. So if you make K subject of the formula, half-life will come down, K will go there. So to get K is therefore equal to 0.693 over 60 minutes. Now, because the answers are in seconds, we have to convert 60 minutes to seconds. So 60 minutes to seconds, you multiply by 60. So K is 0.693 over 60.60. You get this per seconds. So this is the rate constant of this reaction. So I haven't gotten the rate constant, so I'm going to quickly impute it here. So I already know my original to be 100%, and my final is going to just drop by the final concentration of the reactant I want at that point in time I'm looking for is dropping by 1%. So 100 will drop by 1%, 1.0%, I have 99%. So quickly I will impute it. 99 over 100 equals to minus this times time that I'm looking for. I'm looking for the time that 100 return just 99, reduced by 1%. So the time. So I haven't gotten this. I quickly make T subject of the formula. T will make subject of the formula by saying T is equal to this is minus 0.010. So that should be 0.010 minus all over minus 1.925 times 10 raised to the power minus 4. If you press this on your calculator, this is what we're trying to do here. So just find where you can make T subject formula, let this one go under. This one go under. That's what I did. So if you make T subject formula, I get 52.6 seconds. You can confirm on your calculator. So just make the time because it's a short video. To just make it easier, so I just calculated it before solving it. So you get 52.6 seconds of calculating, and that is going to be option D. So you can try this equation for any of your chemical kinetics question. So if you have people on chemical kinetics, I've solved. So if you have issue on first order reaction, these are the solved question of first order reaction. Half-life. Sometimes they can ask you, given that the half-life is this, what is the rate constant for this first order reaction? Can you use this formula? Sometimes they'll say, at what time will the concentration of A be reduced by 10%? So now your 100%, your original will be 100%, reduced by 10%, final will be 90%. You can start solving. They might give you the rate constant, or you find your rate constant yourself. So that's how to solve questions on this kind of questions. That's how to solve this kind of questions, and it's very easy. Make sure you like, share, and subscribe. Share with your friends if it was helpful to you. I know it was helpful. If you don't share it, watch your back.